Hey folks, this is Praveen. I work at Hasura as a senior developer advocate. I've been on this meetup, I think a few months back. So for those of you who are new to this, I work at Hasura as in the community team. A full stack developer primarily, and obviously powered by Stack Overflow for the front end piece of it. And my journey I started off with jQuery, PHP jQuery stack, the LAMP stack, and I moved into the React Angular Vue, the modern front-end tooling, post 2015-16, right, when React actually kicked off. And on the backend side of things, I used PHP before, but then I also used Django for a pretty significant time. Then I moved to Node.js, so JavaScript both on the front and the back. That's been the backend journey, and Docker for packaging and stuff, right? So that's the current tech stack that I work on with. And the reason why I mentioned this is because of how I changed into GraphQL. Because if you look at this journey, I've changed my front-end stack, I've changed my backend stack, but the API layer was actually REST API throughout for a significant amount of journey, right? And GraphQL was actually something that I adopted from 2018 as part of working at Trust as well, right? So, and that journey was interesting because till then, I didn't realize that APIs need to be changed. That's something that you can actually leverage with GraphQL, which was not available before, because the pain points of REST API were not very significantly visible when you're just developing. And there are other problems to worry about in your front-end tooling and your back-end tooling, right? So the REST API pain points were actually hidden behind all of these layers. And hence the journey to GraphQL actually was a turning point, to be honest. So today's topic, I hope that everybody's familiar with GraphQL, and today's slightly advanced around what is caching and why is it different in GraphQL sense when compared to REST APIs. We would love to compare it with REST APIs, right? The devil is in the details. It's basically a single endpoint, so you can't cache your entire server. With REST APIs, you have individual URL endpoints, so it's easier to scope it out into different endpoints and different use cases, and different types of requests as well, right? Which would be like get or post or whatever verbs, HTTP verbs that you can typically use. With GraphQL, most server implementations fall back to HTTP and POST requests to handle all of these requests. Some of them support GET requests, which will help in caching, but we'll come back to that on why that's not scalable. In fact, the easiest reason to give why a GET request cannot scale is because if you're using a mutation or a query in GraphQL with a GET request, there is a limit to how big a URL parameter can be, and you can't use a very deep nested query in GraphQL and put it out in a query parameter. And use variables and stuff. So it becomes slightly not scalable in the long run when using GET requests, right? So that eliminates the possibility of using GET in the long run of GraphQL. So you're restricted to single endpoint, and the comparison with GET and POST is that you're most likely going to use a POST request on HTTP with GraphQL, and I'm ignoring subscriptions where you probably don't need to cache them, which will include WebSockets, and the protocols are different here. So typically, if you just step back and look at what's slowing down a particular GraphQL query, there are different parameters to look at, right? Which is the biggest is in the size of the response. The bigger the response, obviously, it will slow down your entire API call request response cycle. But this is also an important reason because, I mean, size is an obvious choice to put it down. But the reason why size of the response becomes important is because GraphQL lets you query arbitrary nodes. The levels, the depth of your query can be pretty arbitrary because you're giving the flexibility to the user, right? Which means the size of the response could be could vary between different requests. And hence that becomes a significant reason why your GraphQL query can be slowing down. The next big thing is obviously the location of the server. This will boil down to the latency of your query, how close your user is from the request the server is serving it from. Right, so the location of the server becomes another bottleneck on how fast you can serve your users. The third bit I want to focus on is the number of concurrent API calls that your server gets in. And all of these will actually be applicable to your REST API as well, or any other API layer that you've been using. But particularly with size and location with GraphQL, it becomes more important because you allow the users to query what they want. And because the size is actually could become bigger, the location of the server also matters with the latency. And in all of these, there's this factor of just one URL endpoint and one verb, which is HTTP post that you are going to use, right? So just combine these two together, these parameters with the single endpoint and post, and you get to know that this is actually a problem which is very specific to GraphQL, even though some of these are familiar problems that we've solved for REST APIs or other APIs in the past. So let's look at the layers of caching with GraphQL itself. The simplest one is client-side caching, which is actually talked about a lot if you use any front-end libraries, which includes like the Apollo or Urkel on the React side of things. And the client-side caching ensures that the request doesn't even hit the server in the first place. So that is like a very the simplest way of putting cache on the front-end side of things. But this is also limited by how much it can actually help you in your application. But this is actually a very good way to start off with a client-side cache, so that you're not really repeating the number of requests being sent to the server on a dynamic app on the front end. Right, so Apollo and Urkel clients on the front end, React clients, they support normalized caching. So that's a level of caching that you can get started with. And depending on the objects that you send, and depending on what your state of your front-end app is, that will actually be a good place to look at and cache respective data. And they also offer update the cache on mutation and stuff, right? So the API is to update cache on mutation, and you have access to read and write cache. Right, so that's the simplest way of putting out the first layer, which is the client side. The second layer and all the other layers would be on the server side, which is around, to start with, this is response caching. Now this is the data object that you get from your server for any GraphQL request. So this is the data that you want to cache before sending it back to the user. So you typically want to store it in a Redis instance or any other cache store that you are maintaining on the server side. The other parameter to worry about is the database query that you are compiling or creating on the fly. Every time a GraphQL query is made on the server side, you are most likely hitting a database, or you're most likely doing some computation or hitting some external SaaS API, third-party API. Okay? Let's ignore the third-party API for now, but let's focus on the database query bit, which is a primary use case in most applications, right? So the way you optimize your database query is another layer that you have to worry about before even thinking about caching the data objects that you want to send back to the user. Right, so it goes a level deeper into your whole application architecture. A simple example that I can think of with database query caching is how you leverage database specific features. Like, for example, Hasura uses prepared statements, which basically ensures caching is enabled, query caching is enabled at the database layer. Postgres has some features. When you use prepared statements to query Postgres, there is a level of performance improvements that you see, and because Postgres internally actually caches it whenever you're using a prepared statement, it skips execution of certain things and then bypasses it to actually just execute the final output. Right, so that's another layer that you'll also have to think about when you're developing a caching mechanism. And finally, on the server side has multiple components. And finally, it would be around edge caching, which is to solve the problem of the location of the server and the latency, right? So you can cache your response, you can optimize your database performance. But if a user from Asia is requesting to a server in the US, obviously the latency is going to be pretty high, and hence all of these, even if the response is cached, for the user to actually even hit the server, they need to go through from Asia to US, and then the latency will actually be very limiting in performance. Right, so multiple layers on the server side, and the simplest layer is the client side, where you can start off with your existing front-end client tooling. And let's look at even more parameters of caching. So once you've decided that you're going to focus on the server side portions of caching, because client side, you obviously have the libraries to take care of and use the APIs, where there is no change required on the server side portions. So client side is just work that's getting done by a front-end developer on your team. On the server side, you'll have to worry about a few parameters, which is around the cache freshness. How long is the cache going to be there in your Redis instance or your cache store? The expiry of the cache in time interval. Let's say you want to store the cache for for a minute or for how many ever seconds. Right? So the configuration for that has to be taken care of. The reason why this is also important is because you can't infinitely cache and store your data for a pretty long time. And these are correlated because you want to always serve fresh data to the user, but also keeping in mind that if you can't real-time show data, and you can only have like a time interval between which you can refresh this data, right? So there is a control that the user gets to have by refreshing the cache whenever they want to. And there's an expiry time by which the cache itself gets cleared automatically. And this is another important one, which is to say what happens if there is authentication involved in all of the queries. Because so far, if you visualized the parameters, all of them assumes that somebody is making a HTTP POST API call to a single GraphQL endpoint, and then you get some data response back from the server. Now, this caching can be straightforward, but if you involve a layer of authentication, which is to say you have an auth token being sent by the user, and they only have access to very specific data. So, for example, like a user, let's say Paul is a user and Rob is another user, and Paul makes a request to get their own profile pic or image or some personal details like email address and whatnot. And they should be able to only get their own data. And similarly, Rob should be able to get only their own data, right? So this authentication and authorization, if that is a parameter, how do you think about it in caching terms? So here, you will have to ensure that the cache is being fetched for the respective user So if the next time there is a request made by Rob, the same response for Rob that was cached initially is given back. This means that for how many number of users you have in your application, that many unique cache keys have to be maintained, and they'll have their own expiry and refresh rates interval, right? So authentication plays a huge role if you want to cache your authenticated queries. And the use cases are that you might want to cache profile details, which are not going to be updated too often. And hence, the first time you make a request, you cache the response on the server side. And the next time, if you hit the server within a specified time interval, you assume that this is stale data, and then you actually send that data back for the respective user. So unless the user explicitly mentions that they want a refreshed data from the cache, the server assumes that this is the old data and this is the data that I'm going to send back to the client, right? So this means that the server has to maintain unique cache keys for every user request that's being made. So authentication plays a huge role in how you architect your application for caching. And database that I've spoken before, depending on which database you're using, which could be a SQL database or NoSQL database. How do you leverage parameters in your database for performance and not make it as a bottleneck in the long run? And finally, there are external APIs in your resolvers. In a typical GraphQL query, you probably call some SaaS API or some external REST endpoint. How do you leverage caching for those API calls, right? The different ways to approach this. One is to see if that external API itself has its own cache control headers, or if they provide a way to cache the response that they give you. And once that is figured out, you will be able to now cache your response, which is being given back to the client. And whenever there is a refresh or a cache expiry of your current server's cache, you will also ensure that the external API's data is also refetched whenever you send back the data to the client. So external APIs is where external API and database is where things can get tricky. Authentication will be the most trickiest one to handle in terms of parameters related to caching. Expiry and freshness, straightforward. You will figure out the time interval that you require for the app and how much space you want to utilize per response and how much infra you're able to handle for storing cache, right? You will not be able to replicate your database data or some, you don't want to keep that in an in-memory store for a huge size. Because here with authentication being involved, you will have to maintain cache for each user separately. So now that you've seen the parameters, we've also slightly touched upon this, knowing what to cache. And if you look at the use case here, you are like fetching restaurants. And here there is authentication involved, or let's say there are users in the application who belong to different locations who are using the app, right? And in this case, let's say user 1 and 3 belong to SF. They are in the same city, but the user 2 is in a different city, Dublin. And here, even though user ID 1 and 3 are actually separate users, the data that they're fetching is actually relevant, are actually the same because the city that they belong to is the same. So if you look at the listing of a food browsing app or a delivery app, the restaurants that you want to load for user 1 and 3 are the same. So typically what they will do is, the server will do is that the server will load the cache data for SF restaurants. And for the user two, it will be a different cache key with restaurants from Dublin. So here, so this is user specific data, and more so on the location specific data, right? So here is a combination of user property, which is the ID and the city that they're located in, and hence city is a common factor where you're caching data based on this one parameter, and then you're maintaining different cache, right? And obviously, the user can change the location that they are in. They'll manually change it, and then there'll be different API requests. And maybe let's say the user one changes their location from SF to Dublin, and now the response will be from the Dublin restaurant cache. The server will respond it back in that data. So, so this is a rough idea of what to cache. Actually depends on what the parameter is. So this is for a use case of like a restaurant listing page where you want to showcase just the images and the rest of the names and the locations and whatnot. And here the data is common for the users who belong to a same city. But there are other use cases where user ID 1, 2, and 3 each will have its own set of data, which is the profile data. And there you probably may or may not want to cache it, depending on how frequently this page is being visited. If it's a frequently visited page, you would want to keep it in cache. If it's not, then you can skip it. And in case you're actually still going to cache authenticated data with profile information, kind of a use case, that's where the number of cache keys that you're maintaining will become large. It'll be proportional to how many users you actually have in your application, right? So, and the general recommendation is to think about your application, the number of requests being sent, and how frequently they send for this particular GraphQL query. So for example, with a little bit of analytics, you'll be able to tell if people are actually requesting the profile GraphQL query, the profile query to fetch the ID, name, the email of the user in the profile page of the application or the web browser. So if that query is being sent pretty often, and that is also authenticated, which means it depends on the user data, you would want to now store that information in cache. So it totally depends on analytics information on which kind of queries are being frequently accessed by the user. But the general sense is that profile data is authenticated data, and you probably may not need to cache it because the likelihood of them being accessed pretty frequently is kind of low. But the restaurant data, which is the primary interaction of the user, which is the listing of data, right? And this use case is pretty much applicable to all e-commerce applications, right? List of products are catering to a particular location, irrespective of where the user is logged in from. If they belong to a particular city, they'll be seeing the same data, right? This is where this is the naive implementation of caching. Obviously, if there is personalization involved, again, then caching becomes a lot trickier than what we are discussing here. This is all assuming that the data that's being represented for user 1 and 3 are the same, primarily based on what city they are living. Right. So what to cache is an important thing to look at. And it depends on the property of the user, which is the city or the ID or some common parameter which brings a set of users together. Right. So now that you've decided what to cache, and you'll know how to cache it as well, keep it in some instance, you need to know how to update the cache and when to update the cache. So same use case, the restaurant use case, we have the SF restaurant cache. Somebody's making an API call with the restaurant ID, and if and the server will see that if this is still an SF restaurant, the page that is being requested. If it is not, then then it's a different request. But if it is still the SF restaurant, then invalidate the cache after a time interval, right? So the primary use case for updating cache is either the cache has expired for the time interval that they're given, or if some data has changed through a mutation that has happened in the restaurant listing. So the way to think about this is every time there is a mutation through your GraphQL server, you get to know that some data has changed, and you have the ability to reset the cache that you're storing locally. So that's one way of knowing how to update your cache. The other way is by default, your cache expires after a few seconds of the configured interval, right? So that's by default, that keeps happening every 60 seconds or every up to whatever minutes that you want to cache. There is an event that runs which clears the cache by default, irrespective of what's happening. The other use case is if there was a mutation that was done, and as a result of that, if some data changed, you would want to now update or clear the cache and then reset it, and then just load in new data from the mutation change. So that's knowing how to update cache, basically cache invalidation post mutation, and refresh cache depending on what the mutation changes are in this whole process. So let's look at tooling that's available today for caching, and this is primarily considering the JS ecosystem. So we have this envelope response cache plugin with the Redis instance that you create and maintain. And I'll show you the NPM module there as well. This is built by the Guild team. And this is resolver caching for you. There's GraphCDN, which sits at like a gateway layer where your client hits GraphCDN first, and they maintain a cache, an edge cache globally with Fastly, and depending on what kind of queries you're caching with them, they send back the response back to your server. So irrespective of what server what language or library you're using to build a GraphQL server, GraphCDN becomes that API gateway behind which your GraphQL server sits in, and they cache your requests, right? And finally, I'm going to talk about Hasra Cloud as well today with a demo. Here, if you're using Hasra for generating GraphQL APIs pointed to database, you have the ability to cache data both at the database layer, which Hasra provides by default through prepared statements that are being generated by Postgres, and also through Hasra Cloud with response caching, where you can specify which queries you want to cache from your query itself. Whenever you're making a GraphQL query, if you have the @cache directive, you'll be able to make use of that to actually cache the query for a given time. That's the broad set of tooling that's available in the JS side. I've also checked out a few other languages and frameworks. There is, I think, a GraphQL cache gem that's available for Ruby. And I think there's something available for .NET as well with the plugin system that the Hot Chocolate folks have done. With respect to other languages which don't have an explicit cache plugin as such, I think the approach that they've taken so far is the data loader approach, which is sort of a pseudo cache. Because you're trying to basically improve performance at the end of the day, right? So it's not technically caching, but with the right configuration with the data loader plugin, you're trying to improve performance with some of these other frameworks and libraries which don't have an explicit cache plugin. Cool. So I'll go ahead with the demo with Hasura quickly. So just to so I'll just open an existing project that I already have. just to showcase what it means to cache a query and to refresh your data, and how do you approach this from your front end, right? So that's the going to be a simple demo. And meanwhile, once this is opening, I can just quickly show you the envelope response cache plugin. So the approach that these folks have taken is because obviously it's for your custom GraphQL server that you write with let's say a GraphQL JS, or probably with the Polo server that you write. Here you create an instance of Redis and configure it with this plugin, with the response cache plugin. And the way they handle this is by caching data at the resolver layer. So you obviously write resolvers for your queries, and let's consider them as functions or modules, and each function returns some data, and that data is being cached into a Redis instance for whatever configuration with the configuration, such as the time interval that you've given, and it stays in the cache. And this plugin ensures that the cache stays in for only that much time, and then it refreshes based on what's happening at the resolver layer. And if there is a mutation that's being called, there's an automatic invalidation of existing cache, which the plugin takes care of. So there's an automatic cache invalidation as well with this plugin. So the primary architecture is around Redis. Use your existing GraphQL server, add this plugin, and they ensure that the workflow between Redis and the data caching happens automatically for you with the right configuration. Right, so that's this one, and there is on the Ruby side, there's a caching plugin, very similar. You use resolver level caching over here as well, right? I've also written a post which talks about how to do caching with different languages and frameworks. So maybe you can check that out. I can drop the link in a little bit later. But primarily, I think most of the libraries have data loader batching and caching, but not like an explicit response caching plugin, except for the JS library, which is a response cache from the envelope. Right. So this is one post you can look at for other languages and frameworks for caching options. Cool. So I've now opened a Hasura project. I just simply have a few tables here. I think it's probably author table. Yeah, just one table here, which has some dummy data. I think we'll also add more data. Yeah, I have like 3 rows of authors. So let's make a very simple author query, which just fetches the ID and name. And I'm just going to open the network tab as well. I'm going to make the request. And this is, and you've got the response on the right. We've gotten 3 users right now. So let's order this by ID. Let's do descending so that the latest comes in. And let's also probably do limit 1. So this query basically fetches the latest data, right? So the limit for you, but I can just quickly remove the limit to showcase this example. Now, the way to add caching with your Hasura query is to add this directive called @cached, and then you pass in a couple of parameters. You can give in the TTL, the time to refresh it, the time to expire actually. So this would be, let's say this will be in seconds, up to a maximum of 300 seconds, which is like 5 minutes. So you can store your data in cache for up to 5 minutes. If the data response is less than 100 KB in size, right? So let's assume that this cache will exist for 300 seconds, the maximum time that I'm going to use. I'm going to make this query. And if you look at the response, there are these two headers, response headers. I don't know if you can see them, but there's one cache control, which is the max age response, which is 300, which says it's 300 right now during the first query. So I'm going to make another query. And here we can see that the max age has now changed to 274 seconds. So basically 26 seconds have passed in since the first query was made, right? Now what I'm going to do is head to data and add in more data. Probably let's add Paul and look at this. So let's say we've added Paul. Let's go back to API. Let's make I'm just going to clear the network tab. Yeah, I'm going to make the same request now. And despite adding Paul, we've gotten response which is kind of stale right now because we still get ID 3, which is Praveen, and ID 2, which is Praveen. So this is still old data. And that the reason being that it's still using the cached parameter with the 300 TTL, and there's a max age up to 42 still. So till that 5-minute interval, this data will be coming in from the cache, which may or may not be stale. And in this particular case, this is stale data. Now, the way to manually do this refresh is that you can pass in a refresh parameter, which is a Boolean. You can say refresh true. And the moment you do this, you get back the new data as well, or whatever is there in the current response, which is the latest data. So this is the refresh parameter that you use. And this is kind of manual right now. But ideally, what you would want to probably do is whenever you did a mutation, so as soon as you went to data and inserted the row, which is sort of a mutation, right? But whenever you did a mutation through GraphQL, you would want to invalidate the cache that was being maintained for the author table for the previous query that we were maintaining, right? Just the history, this one. So for this particular author query, there was a cache that was being maintained, and I can show you the cache key that was being maintained. And this cache key and this family of cache key needs to be invalidated whenever there is a mutation to the author table. And that's something that will come up soon with Hasura. But if you're building it on your own, these are two things that you have to worry about. You'll have to worry about caching it for a given time interval, and then invalidating the cache whenever there is a mutation that's happening to the same node that's being cached. So here in this case, it's the author node that you're trying to cache initially with the query. And whenever there's a mutation to the author node, either an update or an insert or a delete, in either of these cases, you would want to now invalidate the cache and load the new data set from the DB. So that's the two parameters that you have to worry about. And yeah, that's mostly the demo that I wanted to show you folks. And I think on the resources side of things, we have a page for caching in particular, which is GraphQL/caching. And here you can see like a quick demo that you can try it out, and like how does caching work and what are the parameters that you need to keep in mind. Hasura caches JSON responses up to 100 KB in size right now, and this is, I think, a pretty good limit for a response object. If it's obviously higher, you probably have other reasons and other things to worry about and optimize for, or maybe fetch them in multiple intervals, make multiple queries to fetch data, and then cache them separately. So that's the current status. And even if you're thinking about building it on your own, you don't want to allow for a very large data set to be cached in the same query. Instead, force the client to actually make multiple smaller queries because 100 KB is still a lot of data if you think about it, and you don't want to be fetching in megabytes of data from the cache, and you're basically not solving it for caching. You're basically just overloading your caching solution like Redis by storing in bulk of data. Right? So there's a balance that you need to maintain, and how long you want to maintain that in the cache as well uh, to improve latency and performance. Right. So that's the parameters to look out for when you're building your own solution. And this is what Hasra gives you for you right now. And the end goal is to have edge caching with automatic invalidation of caching when a mutation happens, right? And edge caching will need like a CDN-like interface where you have your servers in all of these locations, either through Cloudflare or Fastly or all of these CDN solutions. And so that will take care of edge caching. And automatic invalidation will just mean that you have to process all your mutations and then invalidate the cache that gets generated as well. So yeah, that's it for my demo. And happy to answer questions.
Thanks so much, Praveen. It's a really great talk. Has anyone got any questions for Praveen?
I've got one in general that Praveen might be able to help with. I am a little bit new to sort of the whole deployment aspect of all this GraphQL stuff, and I'm wondering if there is any differences with caching on a traditional server versus Lambda deployment.
Right. With Lambda, I think, especially with GraphQL, because each Lambda will become its own GraphQL server, especially if you're using, let's say, an Apollo server, which was created for serverless. So each Lambda function will become its own endpoint and server. So you will now need to maintain a different API gateway, which will be your single point of contact. And the gateway will be the single GraphQL endpoint, and the gateway will decide which Lambda function to call based on which GraphQL query, and becomes a complicated setup that you want to maintain over long term. But with Hasura, obviously, what you can do is you can use your Lambdas for GraphQL. You can add them to an existing schema that Hasura maintains, and your endpoint remains the Hasura GraphQL endpoint, wherever you are hosting it, and that endpoint will then proxy to your Lambda automatically. So in that case, if you're using Hasura Cloud or Hasura, the caching is taken care at the Hasura layer. If you're doing it on your own, if you're hosting your own set of Lambda functions, then the caching becomes slightly tricky, because then it has to be done at the API gateway level. So if your gateway is written at, let's say, for example, AWS using Lambdas, then you have to write logic inside your gateway to be able to handle this. And I don't think anybody's done this successfully in production. I've not heard of these use cases where caching is being used in serverless functions with GraphQL.
Okay, that's a very good answer. So I will stop looking for that answer, and I'll think about other ways to solve the problem. Thank you.
Yeah. Yeah, but I'll be curious to also explore caching with serverless functions, but I think fundamentally the architecture is not designed for that kind of a use case. Also, because the reason why you're using Lambdas is because you want to scale them, but also because it's not very frequently accessed. So the APIs that are not super real time, they're the ones that are being used as Lambdas. So not frequently accessed. They can be idle at times, and hence caching that kind of an API is interesting to look at because at the end of the day, the reason why you're caching is because you don't want to hit the actual server which is fetching the data, which means that the actual server can actually be idle during that time of not doing all of these computations. But in a real world app where you actually want to use caching, your primary server shouldn't be serverless. Your primary server should be always available, highly available for all the invalidation and all of these to happen.
Fantastic. Okay, thank you.
If you're doing serverless, you should probably use AppSync instead of using Lambda and API gateway and building your own. Like AppSync does actually support caching inside it. If you are doing it with AppSync if you are doing it with Lambda and API gateway, you can take advantage of things like if you've got data stored outside of the handler, it's available in the next connection. So you can kind of do a little bit of caching to avoid things like accessing databases again and just fetching it sort of from inside your Lambda and storing it inside your Lambda. So there's a few little optimizations you can do, but if you're going to do like serverless GraphQL, just use AppSync. It's a much easier solution.
Okay. I'll have a look into that. The only reason I'm still just in development and playing around in dev, and I'm using Next. So the server's just inherently Lambda. So I'll separate the back end, and it doesn't have to be Lambda. So sounds like it's better to go down either that AppSync way or a more traditional, highly available server.
Yeah, so when we're actually doing GraphQL out of a Lambda and an API gateway at the moment, and it works fine for the most part, to be perfectly honest. We don't have any real problems with it. Again, it sort of comes down to that question, I guess, of performance and what are you scaling for? And like we go with Lambda and API gateway because I don't want to have to care about operations side of things, and I'm more interested in things like availability and scaling for size, and than I am worried about sort of performance. Like the performance is good enough, especially when you can spin up thousands of Lambdas to handle the requests for you. So yeah.
Interesting trade-off. It's too early to know what my bottlenecks are going to be, so I'll have to just keep an eye on that and have these options ready.
Yeah, with Lambdas, I think the advantage is the number of concurrent API calls do not matter because you can scale kind of infinitely. And it's interesting if AppSync users, because with AppSync you can map out external HTTP endpoints, which could be Lambdas as well, and becomes like a serverless stack with the AppSync combination with Lambdas. And that should be an interesting use case to explore as well, both from a performance and if it supports caching. That's also.
Any further questions for Praveen?
Yeah, I have one or two about the cached directive. What's the scope of that directive if you have different query arguments or return from the query a different shape of data? I'm assuming that it will but still have the cache directive there, but it's going to be a different key or cached separately.
Each unique query will have its own key, and if the shape of the data is changing because you're adding more fields, it will have its own key, and that will be cached separately. The response will be slightly different, right? So so it will have its own key. And the cache directive is obviously a custom one that's currently being used by Hasra. The GraphQL spec doesn't say that this is the directive that we used for caching. Different server implementations use different directives. We've started with the cache directive with a couple of arguments to refresh and give the TTL. But we'll probably also add more to invalidate and stuff.
And sort of the opposite, if you issue the exact same query but without the cache directive, does it? I'm assuming it doesn't use the cache that's been set up for that.
Yeah, it will travel to the database. It will hit the database directly and get back you with the latest data. Yeah.
Interesting. Yeah. So to a degree, you're sort of handing over some control over caching to the client. In that case, the client gets to decide. Yeah.
Yeah, and in fact, even if you're passing in the cache directive, if you are enabling this parameter called refresh, which is a boolean to say true, this will actually bypass the cache and it will refresh the cache, which means it's hitting the database and then updating the cache for you as well. So this is another place where you can bypass cache and then temporarily update the cache. If on the front end you know for some reason that something has changed, you can do that as well. This is currently a workaround for invalidation of a cache, because currently the server doesn't do it automatically for you. So if on the client you're doing a mutation, so post mutation you can do this refresh, which will actually refresh the cache and fetch the latest data.